It's going to calculate the energy in joules of electromagnetic radiation with a wavelength of 497 nanometers. And this is a multiple choice where when I cut and paste it from Blackboard, the little circles here didn't transfer. And we can see that there's similar numbers with different exponents. And in order to solve this, so we're talking about energy, we're talking about wavelength, and we've actually got two equations off of our conversion and equation sheet. So we've got energy E, which is equal to h nu, and we've got C equals wavelength times nu. And these are the two equations we're going to have to put together. Let me write those down. And actually, there's a couple different ways you can do this. You can solve first one equation and then the other. You can also put these two equations together to create a new equation and then just plug directly into that. Either method works, and so whatever you're more comfortable with. For this particular problem, let me go ahead and put the two equations together. To do that, I'm going to solve so I can see frequency in each of these. And I'm going to solve, since I'm looking for energy, I'm going to first solve this equation that we just used in the last problem for frequency. To do that, it's going to be frequency equals speed of light over wavelength. Then I'm going to plug that into the energy equation where I see frequency. So E is going to equal h times c over wavelength. And from there, I can now plug in my values. Let me make sure I stay on page here on screen. Planck's constant, of course, is one of the constants that's on our conversion and equation sheet. Let me locate it. Ah, there it is. So Planck's constant's right here, 6.626 times 10 to the negative 34th joule seconds.
Professor, I have a question.
Yeah, go ahead, Wilhelm.
Yes, can you please at the end upload that sheet on the Blackboard?
Yes, so this sheet should be uploaded, and I'll double check, but under the syllabus, and I forget what so syllabus and course schedule folder on Blackboard. It should be there. In fact, I'm pretty sure it is, but I'll double check.
Okay, thank you.
Yeah, and if not, I will make it so, and I'll send out an announcement, but I think it's there. Yes, okay, so we've got h, which is Planck's constant. We've got the speed of light that we need to plug into this equation. 3.00 times 10 to the 8th meters per second. And we've got wavelength, and wavelength is given at 497 nanometers. And one of the things I talked about in the lecture outlines is that you can do a separate conversion to convert nanometers into meters. And we just did this, but let me write it again. Or one of the shortcuts that I suggested in the lecture outlines is that wherever you see the word nanometers, you can just write times 10 to the minus 9 meters. And then enter it into your calculator as 4.97, as I'll show you in a second, exponential 10 to the minus 9. Either way works, and just make sure you get comfortable with a method and make sure that your units work out. Let's see, from a unit analysis, before I plug in the numbers, I've got meters in the denominator, I've got meters in the numerator, those cancel. I've got seconds and 1 over seconds in the numerator, and those cancel, so I will be left with the units that the problem is asking for, joules. And then multiplying this out, let's see if I can do this. There we go. 6.626 exponent 34 negative times 3 exponent 8 divided by 497 exponent 9 minus. And again, that's how you can enter in this term. You could also do the conversion sort of backwards that we did on the previous problem Either way works. I get 3.999, etc., times 10 to the minus 19. We'll round that, like we do for pretty much all problems in this class, to 3 sig figs, which will turn out to be, oh, actually, my answers, which are actually to 4 sig figs, and I think this is a result of a calculation in Blackboard. Let's see, we can tell which one it is. I'm going to write my answer down how I typically do anyway, which would be 4.00 times 10 to the minus 19 joules. That's typically how you would write it for a file upload style problem. But in here we do have 4 choices, and one of them does have a minus 19. This is a multiple choice question. And we can now determine which multiple choice it is. Any questions about that? If not, so I do have one or two other things to say about this. So this is the energy of a wave with a particular wavelength. And what we said was that the smallest packet of electromagnetic radiation is called a photon. And even though it doesn't show up in this calculation, let's see if we can keep that on screen there, we will from time to time add it. And so here's what I mean by that. This is 4.00 times 10 to the minus 19 joules per photon. And I know that doesn't show up in the equation, but it is the energy of a photon. And so let me write that here, is the energy of a photon with wavelength equals 497 nanometers. And we talked about the smallest amount of electromagnetic radiation is 1 wave or 1 photon. And this will come out again once we actually relate these calculations that we're doing to energy absorption by atoms. So I want to throw that in, seemed like a good time. Any questions about that aspect of changing these units here? As you know, I'm a big fan of units. All right, let me stop the video.